Does integral 1 to infinity x minus 2 over x cubed plus 1 dx converge or diverge? Well, one way to answer this is to actually evaluate the integral, but that's going to be longer than necessary. This one is actually fairly easy. We know that if we have, let me put this in a different color here. We know that some integral from 1 to infinity, 1 over x to some power, let's say p dx, that converges or converge for p greater than 1 and diverge if p is greater than 0 and smaller than or equal to 1. So I'm going to use that fact and do a comparison test. Now notice that I want to see what can I compare x minus 2 over x cubed plus 1. So notice that negative 2 makes the numerator smaller. So I can claim that this is smaller than x over x cubed plus 1. And notice that the 1 now here in this 1 in the denominator is making this rational function even smaller. So I can claim that this is smaller than 1 over x to the second. So please remember that, if that 1, let me just use even a different color. Notice that in here, if that 1 was not in the denominator, I would have x over x cubed, which is 1 over x to the second. So if I'm adding something here in the denominator, then this makes it not, now this whole thing is smaller. So now I can claim that this is smaller than 1 over x squared. Okay. And notice that now let's focus on here, which is just like the information that we have. Now I can claim that because the integral from 1 to infinity, 1 over x squared, is converging because this power is greater than 1, it's 2. So now I can claim that by comparison, integral from 1 to infinity, x minus 2 over x cubed plus 1 dx converges. So this one was pretty straightforward. Some of these problems, you have to think about it before you find something that you really can compare with. And so don't get frustrated with them. Worst case scenario, you can just go ahead and just evaluate the integral and find out if it converges or diverges. Let's do another one. So suppose if you want to know integral from 0 to pi sine squared of x over square root of x dx. Does this, so, and the question is that converge or diverge? All right, so let's see, what is it that we know? In this case, I know that sine of x is always between -1 and 1. Okay. And then sine, if I square all, 3 sides, I have to be careful. What happens if I square the sine squared of x? Well, remember that so let me put in negative, put a number line in here. So this is -1 and this is positive 1. And so all these values and of course 0 here. So remember that for the value of sine of x in first step is between -1 and +1 in here. So now for the sine squared, okay, all these values from to the left of 0, let's say -1/2 right here, -1/2. So you see -1/2 becomes -1/2 times -1/2 is +1/4. So it becomes positive. How about -3/4 in here? -3/4 times -3/4 is +9/16. And how about, let's say, -1/4? -1/4 times -1/4 is +1/16. So here, sine squared of x become the smallest that it can be is 0. And the largest it can possibly be is 1 again. So if you're not convinced of that, do some number to convince yourself that that indeed is the case. All right. And now let me go ahead and erase all this, give myself room. Now, if I divide all, excuse me, all three sides by square root of x or x to the 1/2. So this I have x to the 1/2 or square root of x, x to the 1/2, and 0 here divided by x, 0 divided by, x to the 1/2 is just 0. And granting, of course, that x is not 0. So let me just erase this. Now, now that I know that, I'm going to go ahead and go focusing on this. Okay, I know integral from 0 to pi 1 over square root of x dx. Of course, this is improper fraction. This is improper integral. Why is that? Because x cannot be 0. There is a discontinuity at the very edge of this function. All right. So let me go ahead and go to the next page. Now I can claim that limit as x is approaching 0 from right-hand side. Okay. So actually, I better have t because I did have x. So as some t approaching 0 from right-hand side, from t to pi, x to the -1/2 dx. So this is the same as saying this equals limit as t is approaching 0 from positive side. So I get 2 times x to the 1/2, taking the integral of that from t to pi. And that equals limit as t is approaching 0 from right-hand side. So when I plug in pi, I get 2 root pi minus 2 root t. And so what happens as t is approaching 0? So this becomes 0. So this whole thing equals 2 square root of pi. All right. So notice that the function. So now we showed that from 0 to pi. Okay. We showed that from 0 to pi, 1 over root x dx converges. And what did we have in the previous page? We were having, so sine squared of x over x is smaller than or equal to 1 over root x or x to the 1/2. And then we had a 0 here. So notice that because this here converges, by comparison, this is converging. So I can write by comparison test, by comparison test from 0 to pi. And then I had sine squared of, let me give myself room, 0 to pi, sine squared of x all over root x dx converges. Okay, and let's do one more. Just, I think we have time to do one more. So let me go to the next page. And how about something like from 1 to infinity, x over square root of 2 plus x to the power of 6 dx. Does this converge or diverge? So I'm going to write here converge or diverge. Well, let's see if we can do some comparison tests. If this 2 right here, if this 2 wasn't here, I would have then x over square root of x to the power of 6, which is the same as saying x over x cubed, which is the same as saying 1 over x to the second. So now let me test, I know that the integral from 1 to infinity, 1 over x squared dx, okay, I know this is convergent. Why is that? Because of the p-test, so that the power here is greater than 1. Remember that we said that if p is greater than 1, it's, convergent. So I know that this is converging right here. So let's use that fact and let me change color. So here I have, I hope you can agree that square root of 2 plus x to the 6th power is greater than just square root of x to the 6th. Okay, so now what does that tell me? That tells me that x, let me go to the next page. That tells me that x over square root of 2 plus x to the power of 6 is smaller than x over square root of x to the power of 6. And this right here actually is equal to 1 over x to the second. We just showed it up on the other page. So now, and because this is converging and this is the equal to this, then this must be also converging. So I'm going to write that integral from 1 to infinity, x over square root of 2 plus x to the 6 dx is smaller than from 1 to infinity, 1 over x forward dx. So by comparison, it is convergent. Okay, I'll do more in a different video. Thanks.